Okay, folks, here we go. Section 11.10, parametric equations. Let's start with a definition. Systems of parametric equations are a system of equations in the xy plane where the variables x and y are defined as functions of a parameter, usually t. So x and y are going to be defined as functions of a parameter, usually t. And this notation you can see over here. So a system of parametric equations would look like x equals some function of t and y equals some function of t. Now we have seen the parameter t used before. If you think back to the college algebra course, we saw the parameter t when we were solving systems of equations and we had a free variable. Sometimes we needed to introduce a parameter t for our full solution. Okay, quick note. Systems of parametric equations can be graphed on both the TI-84 and the TI-Nspire. Of course, I prefer the Nspire. I'll show you how to do that here in a little bit. The 84, I'll just tell you how to do it and give you a couple warnings. We'll learn how parametric systems work by graphing a couple by hand. Then we'll go ahead and use the calculator to see how it works. Let's start here with example 1. Given the following system, answer the questions below. The system of equations is x equals t squared minus 2. And y equals 2t minus 1 for t greater than or equal to negative 2. So let's start by drawing each graph below. There you have it, folks. I got the graph of x as a function of t. It is a parabola that opens up, but only a partial parabola because we're looking at only when t is greater than or equal to negative 2. And then for y as a function of t, it is linear with a slope of 2, a y-intercept of negative 1, and it starts from t equals negative 2 on up to t as t approaches infinity. Okay, so let's move on to part B of this problem. As t goes from negative 2 to infinity, I have this negative 2 highlighted here because I think on your notes page it may say negative infinity. Not sure whether or not that update's included in your notes. As t goes from negative 2 to infinity, describe the behavior of the graphs of x and y. Example, are they increasing, decreasing, or both? Well, let's take a look at x first. X decreases on the interval from negative 2 to 0 and increases on the interval from 0 to infinity. And the values there, those are t values. For t going from negative 2 to 0, x is decreasing, and then for t going from 0 to infinity, x is increasing. So how about y? Y increases on the interval from negative 2 to infinity. It is always increasing. So we talk about that just to kind of understand the behavior of how each of these graphs works, and then what we're going to do here in a minute is kind of combine each of these ideas and see how the behavior of the behavior of this system of parametric equations. Okay, for part C, I'm asked to complete the table of values below for the parametric system, then plot the graph of the system. When you plot the graph of the system, draw arrows on the graph indicating the direction of the path as t increases. So I've copied the parametric system down here just so I don't have to keep scrolling back up and taking a look at what happens with x and y. But I'm going to go ahead and fill this table out really quickly, and then we'll talk about the graph. All right, so there's our table of values for x as a function of t and y as a function of t. Now let's plot each of these as an ordered pair. So I have first the point 2, negative 5. Then I have the point negative 1, negative 3. Negative 2, negative 1, negative 1, 1, 2, 3, and 7, comma 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Okay, so there's the plotted points. Now we have to show the graph. Okay, the graph of this system starts here when t equals -2, and then it does that, and it says draw arrows on the graph indicating the direction of the path as t increases. So the path of this parametric equation is starting down here at this lower right, or this lower point, and then going this way. So the arrows now are drawn on here indicating the path of the graph as t increases. Okay, so one thing worth noting here is when I graphed x and y previously, they were functions of t. So my independent variable, my horizontal axis was t. Well, now I've converted back into the xy plane, so it's worth noting here that this is now the y-axis again, and this is now the x-axis again. Okay, so let's move on to part D. See if you can solve this system. If the system is solved, you will have one equation in only x and y, and t will be gone. So looking back at the original parametric system, I'm going to go ahead and take a look at it right here. So there's our original parametric system. One thing I notice is that in the variable, or in the function for x, the t is squared, but it's not squared in y. So what I think I'm going to do is I'm going to try and solve this equation here for t. If we start with y equals 2t minus 1, I can solve that for t by adding 1 to both sides and then dividing by 2. So that means t equals y plus 1 all divided by 2. Well, as I mentioned a second ago, I have a t squared in my x equation. So let's go ahead and square this. T squared is going to be y plus 1 quantity squared over 4. And I'm going to leave it like that. If we want to, we could expand that y plus 1 quantity squared, but for now I'm going to leave it like that. So now what do? Well, we have this equation x equals t squared minus 2. Let me go ahead and plug in my expression for t. So if x equals t squared minus 2, that means that x equals y plus 1 quantity squared over 4 minus 2. I'm going to write that in a slightly different format. I'm going to say x equals 1/4 of the quantity y plus 1 squared minus 2. Okay, so there's my answer. And folks, this is a sideways parabola, isn't it? And that's what our graph looks like, so that makes sense. This is a sideways parabola. And we have a vertex. If you remember, this is kind of written in vertex form. And again, if you wanted to expand y plus 1 squared, you could. But the vertex of this is at -2, -1, and we can see that in the graph. And it has a stretch factor of 1/4. But something's wrong, and you guys, something ought to be kind of tingling in the back of your mind saying, hey, this isn't right. If this were a sideways parabola, it would be complete, but this is only partial. And that's because I'm missing a domain restriction on this equation. Okay, notice the smallest y value I can possibly get, is -5. That's when t equals -2. So I need to restrict the domain of this for y greater than or equal to -5. Now that's complete. Okay, folks, that's it for page 1. Let's go ahead and shut this video down, and we'll work on page 2.